Good day everyone, I am Raha Alana Pinkpenton, a grade 12 GAS STEM student. I am here to discuss to you about Lesson 14 Statistical Methods. Before we start off our discussion, what is statistics? Statistics is a term that pertains to your acts of collecting and analyzing numerical data. Doing statistics then means performing some arithmetic procedures like addition, division, subtraction, multiplication, and other mathematical calculations. Statistics demands much of your time and effort, for it is not merely a matter of collecting and examining data, but involves analysis, planning, interpreting, and organizing data in relation to the design of the experimental method you chose. Statistical methods then are ways of gathering, analyzing, and interpreting variable or fluctuating numerical data. There are two types of statistical methodologies. The first one is descriptive statistics. Descriptive statistics describes a certain aspect of a data set by making you calculate the mean, median, mode, and standard deviation. It tells about the placement or position of one data item in relation to the other data, the extent of the distribution or spreading out of data, and whether they are correlations or regressions between or among variables. This kind of statistics does not tell anything about the population. So descriptive statistics in a nutshell are basically organizing and summarizing data using numbers and graphs. For instance, you can summarize your data using bar graphs, histograms, and pie charts. For example, in a science test, 30 out of 40 students were able to receive a passing score. If we will be computing it, this is about 80% of the population of the class. The average score of the class is 82 out of 100. In this example, we were just merely describing the data of our population. The second one is inferential statistics. Inferential statistics used to state something about a larger group population using information collected from a small part of that population, which is the sample. So we are going to use sample to say something about the population. The statistical method is not as simple as the descriptive statistics. This does not focus itself on the features of the category of set, but on the characteristics of the sample that are also true from the population from where you have drawn the sample. There are a lot of hypothesis testing in this method of statistics that require you to perform complex and advanced mathematical operations. An example of inferential statistics is in a sample survey conducted. 65% of Filipino Generation Z prefer to drink milk tea than coffee, while only 34% of Filipino millennials prefer to drink milk tea than coffee. We consider it inferential because the survey cannot interview and get the data from all Gen Z and Filipino millennials. That's why they took a sample from both groups to represent their groups or population. Now, I'm going to discuss about the three types of statistical data analysis. Number one is univariate data analysis. Univariate data analysis is the simplest form of analyzing data. Uni means one, so in other words, your data has only one variable. It does not deal with causes or relationships, and the main purpose of the analysis is to describe the data and find patterns that exist within it. The example of a univariate data can be height. Suppose that the heights of 7 students of a class is recorded. There is only one variable, that is height, and it is not dealing with any cause. The second one is bivariate data. Bivariate data analysis refers to a statistical data set that involves two different variables. These variables are often denoted as x and y, and they are used to analyze the relationship or association between them. Bivariate data is commonly represented in a scatter plot where each data point corresponds to a pair of values for the two variables. The analysis of this data deals with causes and relationships, and analysis is done to find out the relationship among the two variables. An example of bivariate data is, let's say you have to study the relationship between the age and the systolic blood pressure in a company. You have a sample of 10 workers aged 30 to 50 years. Now, we need to display the table graphically to be able to make some conclusions. The above scatter plot illustrates that the value seems to grow around a straight line, and it shows that there is a possible linear relationship between the age and systolic blood pressure. And the last one is multivariate data analysis. Multivariate data refers to a statistical data set that involves multiple variables or attributes, typically more than two. These variables can be related or unrelated, and they are used to capture and analyze complex relationships and patterns within the data. Multivariate data analysis aims to understand how these variables interact with each other, how they collectively influence outcomes or observations. The main purpose of multivariate data analysis is to study the relationship among them. And that is all for my report.
Hello everyone, this is the continuation of Ms. Benton's discussion about the statistical methods. So now I'm going to discuss to you the statistical method of bivariate analysis. Bivariate analysis happens by the means of the following methods. The first method is the correlation or covariation. It describes the relationship between the two variables and also tests the strength or significance of their linear relation. This is a relationship that makes both variables getting the same higher score, or as we say, one getting a higher score and the other one is a lower score. Covariance is the statistical term to measure the extent of the change in the relationship of two random variables. Random variables are data with varied values like those ones in the interval level or scale. Strongly disagree, neutral, agree, and strongly agree. That values depend on the subjectivity of the respondents. Example of correlation and covariance is in one study, a scientist looks at the covariance between two variables outdoor, the temperature and ice cream consumption. The covariance for this data set is calculated as 35.89. These values mean that the two variables move in the same direction each other, so that as one rises, so does the other. Therefore, as temperature increases, the amount of ice cream eaten also increases. Now, let's go on to the second method of statistical bivariate analysis, the cross tabulation. Cross tabulation is also crosstab or student contingency table that follows the format of matrix that is made up of lines of numbers, symbols, and other expressions. Similar to one type of graph is called table. Matrix arranges data in rows and columns. By displaying the frequency and percentage distribution of data, a crosstab explains the reason behind the relationship of two variables and the effect of one variable on the other variable. If the table compares data on only two variables, such table is called bivariate table. Researchers use cross-tabulation to examine the relationship within the data that is not really evident. It is quite useful in market research studies and surveys. A crosstab report shows the connection between two or more questions asked in the study. Now let's go on to the measure of correlation. The following are the statistical tests to measure correlation or covariation. First is the correlation coefficient. This is a measure of the strength and the direction of the linear relationship between variables and likewise gives the extent of dependence between two variables, meaning the effect of one variable on the other variable. The correlation coefficient is measured on a scale that varies from plus 1 through 0 to -1. Complete correlation between two variables is expressed by either positive 1 or negative 1. When one variable increases as the other increases, the correlation is positive. When one decreases as the other increases, it is negative. This is determined through the following statistical test for correlation coefficient. First is the Spearman's rule. Second is person's product moment correlation. The next is the chi-square, and the last is t-test. So first, Spearman's rule. The test to measure the dependence of the dependent variable on the independent variable. Next one is the person product moment correlation. It measures the strength and direction of the linear relationship of two variables and of the association between interval and ordinal variables. Next is the chi-square. It is the statistical test for bivariate analysis of nominal variables, especially to test the null hypothesis. It is whether or not the relationship exists between or among variables, and tells the probability that the relationship is caused by chance. Next is the t-test. It evaluates the probability that the mean of the sample reflects the mean of the population from where the sample was drawn. It is also tests the difference between two means, the sample mean and the population mean. The ANOVA, or analysis of variance, also uses t-test to determine the variance or the difference between the predicted number of the sample and the actual measurement. The ANOVA is of various types, such as the following. First is the one-way analysis of variance. It is the study of the effects of the independent variables. The next one is the ANCOVA, or analysis of covariation. Study of two or more dependent variables that are correlated with one another. The last one is the MANCOVA, or multiple analysis of covariation. Multiple analysis of one or more independent variables and one dependent variable to see if the independent variables affect to another. The second measure of correlation is the regression. Regression is similar to correlation. Regression determines the existence of variable relationships, but does more than this by determining the following. First is which between the independent and dependent variable can signal the presence of another variable. The second one is the how strong the relationship between the two variables are. The last one is when an independent variable is statistically significant as a soothsayer or predictor.